EC does not stand for a kind of fan. It stands for electronically commutated, and it describes how the motor decides when to switch current between its windings. Once you know what commutation is, the whole EC versus AC argument stops being marketing and becomes something you can actually check. Start with the problem every motor has to solve. To keep a rotor turning, the magnetic field pushing it has to keep moving ahead of it. Something has to keep switching which winding is energized, at exactly the right moment, forever. That switching is commutation, and the only real question is what does the switching? In a brushed motor, physical carbon brushes rub against a commutator and do it mechanically. In an induction motor running on mains AC, the alternating supply itself does it, which is simple but ties the motor's speed to the supply frequency and always wastes energy inducing current in the rotor. In an EC motor, electronics do it. A controller watches where the rotor actually is and switches the windings to match. That is why an EC fan looks different when you take it apart. Here is the real geometry: the impeller, the rotor hub it clamps to, the stator housing that drives it, the mounting plate, and the terminal box where both power and a control signal arrive. There is no brush gear, no separate drive, and no shaft running out to a pulley. Look at where the motor sits. The rotor is on the outside, wrapped around the stator, and the impeller mounts straight onto its face. This is an external rotor motor, and it is the normal arrangement for EC fans because the impeller and the rotating part of the motor become one assembly. Nothing is lost in a belt, a coupling, or a gearbox, because there are none. Now the consequence that matters most. Because electronics decide the switching, they can also decide the rate. Speed is no longer chained to the supply frequency, so the fan can run at any speed within its range, continuously, and hold it under changing load. You are not stepping between 2 or 3 fixed speeds. You are setting a value. That is what the second pair of wires in the terminal box is for. An EC fan normally accepts a 0 to 10 volt analog signal, or a PWM duty cycle, and many also speak a digital protocol. Feed it a set point and the controller does the rest, which is why EC fans slot into building controls without a separate drive on the wall. The efficiency argument follows from the same physics, and it is worth stating precisely. An induction motor has to induce current in the rotor to make rotor field, and that induction has a cost that never goes away. An EC motor's rotor carries permanent magnets, so its field is simply there. That removes a loss term rather than optimizing one, and the gap is largest exactly where fans spend most of their life, which is at part load. Be careful with the claims around that last point, including ours. How much energy an EC fan saves you depends on your duty profile, how many hours you run at part load, and what you are replacing. A number quoted for someone else's system is not a number for yours, and any honest supplier will ask about your operating hours before quoting a saving. There are real costs on the other side. The electronics are inside the motor, so the assembly is more expensive to buy and it has a temperature limit that a plain induction motor does not. The drive is not a separate box you can swap in 5 minutes. If the electronics fail, you are replacing a motor, not a controller on a wall. There is also a wiring consideration people meet the first time. Switched electronics generate electrical noise, so EC fans need their grounding and cable screening done properly, and the control wiring kept away from the power wiring. Done right, this is a non-issue. Done casually, it produces intermittent faults that look like a failing fan and are not. So the useful summary is this. EC means the switching is done by electronics, which buys you continuous speed control, a simple control interface, and a genuine efficiency advantage at part load, at the price of a higher purchase cost, a temperature limit, and a little wiring discipline. If you want to know what it would do in your system, send your duty profile and running hours rather than asking for a percentage.